Okay, today we're talking about, oh, it's so nice to have my two screens again. Today we're talking about asynchronous JavaScript. So that kind of includes the concept of asynchronicity, what does it mean, APIs, and then this fun word called fetch. Hold on, let me make sure that I got rid of my practice code. Okay, great. Yeah, so big concepts here. These are some of JavaScript's biggest concepts that we're going to be working with today. Can everyone see my screen? I don't see the green bar. Yeah? It's there? Okay. So we'll talk about async JavaScript. We'll talk about JavaScript is a single-threaded non-blocking language. We'll talk about what that means. And then the call stack and event loop. And I have some extra homework for you all after the lecture is over. I have a video that's about 30 minutes that I want you to watch. If you watch it on 1.5 speed, it's about 20 minutes. And you'll probably want to watch it more than one time. It's not essential to understanding anything that you need to know to pass your project, but it will definitely give you a deeper understanding of JavaScript and a deeper understanding of what we kind of talk about when we talk about these things, okay? We'll also think about why is this functionality important for JavaScript to have. We'll talk about the concept of APIs. APIs stand for Application Programming Interface, and there are a bunch of things that APIs can refer to. And then we'll kind of peek at what our Rails applications are going to look like later. That's going to be our lecture tomorrow. And then we'll talk about fetch, this really important method built into the browser that we use to gather information that's living on a different server. We'll talk about promises. If you, I don't know, I always go into the social channel and post a bunch of memes or songs that have the word promise in it. If you can think of a song that has the word promise in it or in the title, let's just really uplift the promise word today. And then we'll talk about exploring the limits of promises. So how we get information using promises and what we can do with the promises, the information ultimately, okay? So when we talk about JavaScript as a single-threaded, non-blocking language, let's start with single-threaded. So think single-threaded is similar to Ruby, right? JavaScript and Ruby can really only do one thing at a time. They follow a single thread, okay? What non-blocking means is that non-blocking means that when a bit of code needs time to process in JavaScript, there is something built in that allows code to continue even through, what am I trying to say? So if there are methods or functions that we have, and one of those functions is going to take an uncertain amount of time, right? JavaScript will allow the application to keep running function executions going down the code and can basically, put that function that might take a little bit longer at the end of this call stack, right? So we'll get to this in a little bit. If this is a concept that you don't understand quite yet, we're about to dive into it right now. So let's take a bit of this Ruby code, for example, flashback. Okay. So if I open this up in my terminal, if I say Ruby blocking.rb, we'll see that our code says, oh, it sleeps for 1 second. Then it puts out hi, sleeps for 1 second, and says just waking up, right? What this means is that when we have this sleep method that takes 1 second, right? Ruby needs this method to complete before it will continue to the next line of code, okay? This is a blocking language. So this is the opposite of JavaScript. Remember, JavaScript and Ruby are both single-threaded languages, but Ruby is blocking, meaning, hey, this is going to take 1 second to do. We're going to sit here and wait for this 1 second to elapse before we continue, okay? In JavaScript, that is not the case. So I want you all to look at this function, and in the chat, I want you all to write the order in which you think these things will print out in the console, okay? So read over this, and we have some strings here. Write in the chat what order you think they're going to appear. These look great. Exactly, okay? So if we open up this in the console, or open this up in the browser, this is going to be something that we look at later, and then I have to connect this JavaScript file. You get, oh, rubs eyes, yawns, hi, just waking up, right? If we look at the order here, many of you guessed it correctly. Why is this without from yesterday? So the JavaScript code runs from top to bottom. You get oh. And then we have this set timeout, and it waits for 1 second. But the console log says hi, right? What JavaScript does is it recognizes that set timeout is one of our asynchronous functions, right? And there are basically 2 that we're going to use. One of them is set timeout. The other one is going to be fetch. We're going to see it later. Right, so when JavaScript sees set timeout, it invokes the function, but it says this is going to take this specified amount of time. Okay, so it's going to put this basically in another place for that time to wait, and it will continue running through the code. So then the console logs rubs eyes and yawns, and then here again we have a 2-second wait, right? And then so set timeout, this function, right, gets also put on this kind of this separate area where we're waiting for this time to elapse. And then once these have completed and this time has elapsed, then they appear in the console. Okay, are there any questions about this? This is different than our blocking language, right? Because although these are going to take some time to complete, JavaScript keeps on going. Any questions? Okay, what if I did this? What do y'all think is going to happen now? So Osha and Ryan say that it's not going to change. It's still going to run in this order. David says it's going to run in the order that they're listed, which might make sense because we have this set timeout, but we have 0, so don't wait at any time. Can I get some more opinions? So Matt says same as before. Does anyone else think that it's going to run in the order that they're listed? John thinks they're going to run in the order that they're listed. I do. Morgan thinks they're going to run in the previous order. Okay, let's take a look. Let me make sure that I always forget to open this up in the incognito window. But surprise, they run in the same order as before. Okay. They do not run in order. And that is because while JavaScript is a non-blocking language, it is still a single-threaded language. Okay. And so we are going to have to take a closer look at what this thing is called, this concept called the call stack and the event queue. Okay. So what happens is, as our JavaScript program runs from top to bottom, these functions get put on what's called a call stack. So the console log, the set timeout, the console log, and the set timeout get put on the call stack right here from bottom to top, okay? And then they get executed from the bottom to the top. So the console log is gonna run, okay? And then I wonder if I can get my annotations to work. So first the console log is gonna run, and then the set timeout is gonna run, okay? But when the set timeout runs, JavaScript notices that it is an asynchronous function, okay? And the asynchronous function will get sent to this web API, right, to wait out its time, Okay, meanwhile, JavaScript is going to continue to run this console log, and then this set timeout is also going to come over here to this kind of waiting room, right, for this time to complete. Okay? Once they've completed, they come back here, the functions come back down here, okay? And they wait until this call stack has finished running everything in it. Once the call stack is clear, JavaScript takes whatever is on the event queue and then pops it back onto the call stack. And then once that one runs, it'll be clear, and then it sends the second one. Okay, this is what the video that I'm going to send out later is about. But basically, it's important to remember that whenever we use set timeout, it's not that these are going to invoke immediately at 0 seconds, right? Or if we were to change these back to say 1000 and 2000, it's not to say that these are going to execute exactly in 1 second and exactly 2 seconds. This is the minimum amount of time it will take for these to execute, because we have to wait for the call stack to finish before any event that is delegated to this area, this event table, right, has to execute, finish, and go to the event queue. And then the event queue has to wait for the call stack to be completely cleared before it puts functions back on there. Okay? So this is how JavaScript creates this feeling of asynchronicity, or this feeling that multiple things are happening at one time. These web APIs allow events to run in the background. It's true, right? But as far as the order in which JavaScript can run events, it's still just one event at a time. Okay? So if you don't understand this right now, it's okay. Watch that video. I think it'll be super helpful. And he gives lots of examples and demonstrations of how this works. Okay, but we can see this in our own. Let me clear these out. And let me get that other page open. Right. We see here that Hi and Just Waking Up were given 0 seconds to execute. However, they still executed at the very end. Okay. Any questions about this? All right, let's keep going. What was the next thing that I was going to talk about? Okay, so why is this functionality important for JavaScript to have? Anyone feel free to unmute yourself and kind of just think out loud about why do we want asynchronous code in JavaScript? We talked about this before.
So that when something's loading, it doesn't.
Because that way pages can load quicker. So when a user goes, it can load certain parts while requesting other information from the server, but not totally keep the page blank.
Yeah. Bryce, did you have something to add to that?
No, that was it.
Okay, yeah. So basically we want JavaScript to present information on the screen so that the user gets the sense that something is happening, right? That's kind of the primary reason. This has changed a little bit with what we call server-side rendering, which means that there are things that are loaded on the server and sent to the browser directly. So there's like a shell of a web page. But you know, there are lots of reasons why we want this, right? When someone submits something, we maybe want to put like a spinning bar, right? Anything that kind of gets the user to understand that there are lots of things going on, but there's still stuff here you can interact with, right? It's exactly right. So let's talk about APIs, okay? Well, remember when I first talked about that Flatiron News website that I demoed when I was just kind of basically going over the basics of JavaScript? I said that in our applications, we're now just going to be using one single index.html page, right? And in that index.html page, we have to kind of create a shell for what we want our application to be like. But the reality is that the information that's going to populate that shell is going to come from somewhere else. So in the application that we're going to make today, I have this application that's going to show me the first 10 gardening books and I'm going to use the Google Books API, okay? Obviously, someone could publish a book about gardening, and it could become the #1 best-selling book and somehow end up on the first page of the Google Books API on gardening, right? Or if I wanted to make a website that was about news, right, every morning's headlines were going to be different. So we never want to hard code the HTML for our headlines or for things that are dynamic, that change every day, right? That information is stored on what we call APIs. APIs are, like I mentioned here, a very kind of ambiguous term. The internet calls a lot of things APIs. Web documentation can be called an API. So a lot of times, instead of people saying Rails documentation, they'll say, have you read the Rails API, right? People will say, like the built-in functionality that we were just looking at when we were talking about JavaScript in the call stack, this is also kind of called a web API. It's just a bit of technology that has one single responsibility, right? And then APIs can also refer to information stored on web servers that can be used to populate information on applications. So 3 super different things that people call APIs. They basically just stand for Application Programming Interface. So you can really kind of run with that ambiguous description, okay? But keep that in mind. There are 3 really kind of distinct, confusing terms that someone can refer to as an API. But the one that we're going to be focusing on today, well, I guess we've already focused on built-in functionality to applications that exist users and programmers, right? So we're talking about the API, set timeout being one of those. Ajax is the one that we're going to look at when we're talking about fetch. But I now want to pivot our focus to information stored on web servers that can be used to populate info on applications. Okay, so we can go to the Google Books API here. And there are a bunch of APIs. Spotify has an API, Seamless and like Yelp have APIs, Google Books has an API. Basically, most applications that we work with every day, almost all of them have all of your information stored on APIs. They're building your application similar to the way that we're doing it. There's a back-end application and there's a front-end application. So when you log into Instagram or Facebook or Gmail, there's a front-end application, right, that's making a request to an API to get information about you. And that information comes in a specific kind of packaging that we call JSON. JSON stands for JavaScript Object Notation. But however, there are other kinds of formats that you might be able to see, like YAML or XML. I think that JSON is probably the most common one that we're going to use, and is Jason here because now is the time where we would basically kind of point and laugh, and he's now going to be the butt of all JavaScript jokes for the rest of the section. JavaScript object notation. Yeah, where was I? Okay, so here, Google Books, I forget exactly how to get there. Using the API. Most APIs tell you how we can access them. And in this case today, we want to perform a search. So here, let's kind of open up the books.google.com, and this isn't going to work, I think, because I'm in Mexico and we're gonna get a lot of maybe Spanish responses. No, okay, great. So I went into the Google Books website and I typed in gardening, and here are the first kind of 10 books that come up. So Google is basically giving us access to their API that they use to populate this website, okay? And that's basically when you see APIs, that's what they're basically doing. Like, hey, there's this service that we use inside of our own applications to get it to run, and we're making it public. We're making it so you can use it too. If you're a developer and we have pertinent information that you want to use, we've decided to open that up and share that with you. And the coding community is generally pretty open about making sure that there are these kind of resources available, right? So that any creator can go out there and use this, like, you know, hardly earned data, hard-earned data to make your own thing, right? So we should be grateful that that's kind of part of the online community, right? Accessibility to information. So Google Books is saying, hey, cool, if you want access to this exact same information, all you need to do is go to this endpoint, https://www.googleapis.com/books/v1/volumes, and then you put your search term here at the end. So I'm going to do the same thing, and I'm going to type in gardening. And over here, we see that gardening provides us the same titles as the results from the Google search. Okay. One quick side note is that you see that the JSON information here, and again, this is called JSON format. It really just looks like an object. JavaScript object notation just means take the information and make it one big object. Okay. So basically, whenever you get something returned to you, it's going to look like an object. All right. Notice here, though, how the information is kind of hard to kind of parse through, right? It's all kind of splayed out for you and not super easy to kind of navigate. We don't need a lot of this information. So if you're using Google Chrome, I would encourage all of you to download this extension called JSON Formatter, okay? And JSON Formatter makes your JSON look like this, right? It's easily collapsible so that we can kind of navigate our JSON responses a little bit more easily. I wish that they weren't always open though, right? And then we can kind of see like, okay, so when we make a request to this URL, we have a single object returned to us. That object that's returned to us has 3 keys, right? Kind, total items, and then items itself, right? And then when we open up items, we see that we have an array of the first 10, right? These aren't all of them, but we're getting them kind of in batches of 10. And there should be instructions in the Google Books API on how to move through the pages, but I won't worry about that right now. I'm sure that there are some, there's got to be something in here. It's probably just some kind of extra key that you add at the end. But we see that in the items key, there is an array of 10 objects, and each of these objects houses one single volume, right? And we open up the, right, this is an object with key value pairs. If we open up the key of info, we see that there's another object, and we get the title, some authors, how many pages are in the book, some image links if we want them for thumbnails, etc. Right? So if you don't feel comfortable with nested objects and arrays, you know, moving forward, this is the reality of kind of what we're going to be traversing. It's a lot of work. I don't think that we've done this kind of iteration since, you know, early Ruby days. But you know, there's a lot of information that Google needs to kind of make this possible, right? We can imagine that a lot of this information is utilized in the building of this these little HTML blocks. Okay. Any questions so far? So tomorrow we're going to talk about how we're going to make Rails applications that do just this, right? How do we get everything in our database to appear in a JSON format like this so that when I make a request to localhost 3000/students, I no longer am getting the index page for the students. I'm instead getting a JSON object, right, that has you know, all of my students' information inside of it. And how can I use the JSON from that backend application to populate my JavaScript application, right? So here's the big divide between Rails as a full stack programming language, which it absolutely is. But most modern frameworks use JavaScript front-end applications and have separate backend applications that are solely responsible for returning information as JSON like this whenever we make a certain request. Okay? We will talk about formatting. Tomorrow we'll talk about JSON and API constructing kind of principles and all that jazz. Okay. No questions about what the concept of an API is. When we mean, go ahead. Oh, sorry, I thought someone was speaking. All right, so how do we, as JavaScript developers, get this information from this API to our applications, right? The goal of my application is to, when the page loads, get those first 10 gardening books up here, just the titles. That's all I really want so far, right? Really quickly, if we look at my HTML, all I have is one kind of div called results container. It has kind of like a title that I kind of sloppily put in there and without using a tag at all. And then we have this UID, UL with an ID of list. And inside of here is where we're going to want to put all of our titles as LIs. Okay. So we will be using fetch. Fetch is a way to make XML HTTP requests to receive information from a server. We're not going to dive too much into this, but fetch is basically a built-in method in the browser that uses this technology to retrieve that information that we want. Okay. And fetch requests whenever you use fetch, the default value is a get request. Okay. So get requests, again, are equivalent to just what we type into our address bar, right? So when I visited this link, I basically made a get request to this, what we call an endpoint, right? And I thought that I had JSON formatter. Maybe I have the settings so that, oh yeah, on all sites, there you go, to get this information. So how we do that is we simply write inside of our index.js file. I've already grabbed the book list element, and I have my URL here for gardening. I should just call this gardening URL, right? And we can imagine that we can make this dynamic, right? We can kind of leave this would be something like a base URL, right? And then we could, use string concatenation to add our own kind of terms at the end, right? To make this a dynamic URL and to make our application populate with different information. Maybe we want books about dinosaurs or books about magic or whatever, okay? So here's our gardening URL. And again, fetch is built right into the browser. So we can simply just call fetch here and then pass in the string of our URL. Obviously, you can pass in the string directly, or you can pass in a variable, okay? And what this does is it is going to return something very strange. Does anyone know what this is going to return?
The promise?
A promise. So inside of my console here, I'm going to type in return from fetch. And we see that the return value is a promise. Okay, really weird. What is a promise? Big question, right? Promises are strange bits of JavaScript that basically house information that take an undetermined amount of time to complete, right? Imagine that you are building your own Rails backend API and you're testing something out, and you'd want to put a buy bug in your Rails application. We remember from our Rails applications, if we submitted a form and that form went to an action in the controller that had a buy bug in it, the application on the browser would have that spinning symbol that says, hey, we're waiting on a response back, right? Same thing happens in JavaScript. If you make a fetch request to an application that has a buy bug in that controller action, the front end is going to be waiting, right? JavaScript has created a promise and said, hey, we went to go retrieve information. I literally can't tell you how long it's going to take for that information to come back, right? So in order to do this, JavaScript needed to create a kind of object to handle this technology, right? We can't guarantee how long it's going to take for this information to be retrieved. Hence, we use what's called a promise. I can't believe I just used the word hence. I don't think that I've ever used that in a lecture before. So let's take a look at fetch in a different way. We can let's see. So how did I do this yesterday? Let's console log return from fetch right after we make that fetch request. Okay. And then what I'm going to do is I'm going to call return from fetch in the console later. Look how the same variable has two separate values. The first value is a promise that's pending, meaning, hey, we haven't gotten the response back yet. So in the millisecond that it took for the fetch request to fire and the console log to run, we hadn't gotten the response back from the server yet. However, in those few seconds that I waited before I typed in the variable in here, right, the promise went from pending to fulfilled, right? So a promise can have two statuses, pending or fulfilled, resolved or unresolved, okay? We see that it also comes with a response. Because of this, it makes it a little bit strange to deal with information that we get back from promises. There are some tricky ways that we can do it. We can use also new syntax to kind of constrain these wildly unpredictable promises into something that's more feasibly kind of synchronous in a way. And I think I'm going to talk about that technology next week. I'm not going to talk about it today. I just want to focus on fetch for a little bit. Promises are also a really elusive topic. We can make our own promises. We can say new promise, and then we can take the resolved function or the unresolved function, and then we can, I don't know, we can do a bunch of weird stuff. We can make our own promises from scratch if we want. I personally have never had to do that. I will link documentation here so you can kind of see. But we can make our own promises. Promises aren't the only thing that fetch can use. If you, for some weird, strange reason in your application, need to create an asynchronous kind of object that needs to wait a certain amount of time to do something, right? There are definitely real-world applications for this. In Flatiron School for your projects, probably not. But again, we can create our own promises and we can determine what they do if they're resolved or unresolved. But fetch itself returns a promise. And what I was trying to say was that fetch hold on, where's the chat? There it is. Okay. So yeah, so it's kind of hard to handle information that we receive from fetch because we don't always know when that information is going to be complete, right? I can't do anything with this immediately afterwards because it's going to take a little bit longer for the response to complete, right? So there is this fancy kind of syntax that we can chain onto promises, this method that we can chain onto promises that waits until a promise is resolved before it executes the next thing. And that is called .then. Okay? You may often see people chain them like this, which totally works. It's just a little bit nicer to look at, okay? Whenever we receive information from an API, the first thing that we have to do is format it to a JSON object, right? Because the response when it comes from, if I console log the response here, this is the response that we get, right? And we want to take this body here and we want to turn it into a JSON object, okay? So what we want to do is we will take that response and we will return that response with the body formatted as JSON, okay? What .then does, it also returns a promise. So we've kind of created a chain of promises now, and by using this .then method, we are kind of creating a sense of synchronicity in this very asynchronous function because .then will only run when the return value from the previous promise is resolved, right? So we're guaranteeing that we're chaining the events right? And these functions are going to run in order. You'll notice too that whenever we're using .then, what gets passed into the function that we define inside is the return value, or the response from the previous promise. Okay. So I've returned this previous response's body formatted as JSON. And now I'm going to console log it here. And if we test this out in the browser, we see that we now have that original object that we were looking for. Okay. I'll let you know now that basically all of your fetch requests are going to start with this. There is a newer syntax that does this. I'm forgetting what it is right now. I think it might be Ajax. That kind of cuts out this middle function. But for the purposes of understanding what's going on behind the scenes, I just want everyone to get in the habit of always making a fetch request to an API and just throwing this function in there. Because it's important for you to remember that we're taking the response's body, and we're taking the body and we're making it into a JSON format so that we can use it inside of our application. Okay. But from this .then chain alone, we've now arrived at a place where we have that information and we can begin to use it. Are there any questions so far? All right, so what a lot of students have a temptation to do is to try to take the information from inside of a promise and save it to a variable, right? And we've seen so far that it's impossible or very difficult to do that because we don't know how long it's going to take for this function, or sorry, how long it's going to take for our fetch request to return any type of value, right? And so if we try to save this bit of code to a variable, right, and then use it elsewhere in our application, it has a good chance of failing us, right? And that's why we should always constrain ourselves to using this .then chain, because we guarantee that we have the information and then we can do something with it once we know that we have it, right? So we should never try to, let's see, so if I write another function that says I have my Google Books object, I'll just say like gbooks object. I should never try to do something like let gbooks object, and then, you know, say gbooks object, or I guess maybe that shouldn't be, you know, gbooks object equals, or gbooks equals gbooks object, right? This is me trying to get this bit of information from inside of this promise outside of it, right? Because it feels more comfortable to do it that way, right? It makes more sense for us to try to say, okay, how do I just get this bit of information and put it back in my application so that I can just use it whenever I want it, right? And there are certain ways to do that. I'm not going to say that there aren't, but for the purposes of learning this material as a beginner, I'm going to encourage you all to never try to get the information from inside of a fetch request outside of it. What I mean is, let's use that information right here and right now. Okay. So the goal here is to take the first 10, each of these 10 original items, right? And I just want to take their, need to get into their volume info, I need to get into their title, and I want to append that title to the DOM. right? So how do I get to, I guess I can just, I have this object now, right? And I can maybe say, let's just console, let's use our debugger now. This would be a cool place to use our debugger, right? Let's put our debugger here. And once we've hit our debugger, we can go into our console. And I know that we have access to this variable here, this gbooks object. Okay. I know that I can call gbooks object.items, and I get my 10 items, right? I know that inside of one of these items, there is a key called volume info. And I know that inside volume info, I can grab the title. So can anyone think of an efficient way to quickly grab the title from each of these volumes, for each of these items? Burbage?
I always forget if you could use a for in or for of loop.
Wait, hold on, Burbage raised his hand.
Sorry.
So we could write a callback function. It's like add books to DOM or something that lets our response items return that book, volume info, and title.
I like where you're going, but I want us to build out everything necessary first and then refactor and think to ourselves, how can we maybe split this out a little bit? But you're on the right track. I see OSHA in the chat. I see OSHA in the chat says for each, right? We can iterate over each of these. And while I don't think that for each is the right one to use, there is an even more efficient one, right? For in, not quite, Matt. So I have an array here. If I want to iterate over an array and I want to get a new array with information from the old array, what should I use? Morgan is right. We're going to map, right? I want to map over each of these. And Morgan, can you tell me what might go in here?
We would have to call on, we'd have to create a new array to push the objects into after we, perform whatever action we want to perform on them.
But map makes the new array for us, so we don't need to make a new array and map and push anything in.
I'm not sure then.
Can anyone else step in here and figure out how we could use map here? If I want to grab the volume, if each of these items is an object with a key of volume info, and that also is an object with a key of title, Regina's right. We have return, each item has is an object with a key of volume info, and volume info is also an object with a key of title. And by doing this alone, I get my 10 titles. Okay. So I'll write that right into my code here. I'll say let titles equal gbooks object dot items dot map function for each item. I want to return the item volume info dot title. Okay. And then once I have my titles, we can do exactly what Burbage said, right? We can write a function that appends this information to the DOM. Okay, so can anyone maybe tell me, or Burbage, if you want to jump back in, what method would I write to iterate over all of these titles and make them LIs on the DOM? Oh, you're muted, by the way.
For each.
Okay, exactly. So we'll say titles.forEach. And what do we want to do with each title?
Like results.enter HTML equal, and then we'll add our li string in there.
Okay, so it'll actually be book list, right?
Yeah.
booklist.innerHTML. And what operator am I going to use here? Do you remember?
Oh, crap.
How am I going to append something to an HTML instead of, right? Juan and Regina have it in the chat.
Yep.
Right? We want to add, if we use the equal sign, we're always going to erase what we put before. But if we use plus equals, we're appending, right? And I can say li, and interpolate the title right here. Okay? So let's see how this looks. I'm going to take my debugger out. Boom. It took a little bit of time, but you see we got it. So this is what I mean by saying, let's never try to take the information that we receive from a fetch request outside of it. Let's use it right here where we know we have it for sure.
Chris, can you elaborate again on why?
Because if we ever try to take this bit of information and put it outside, so again, let's imagine that I have let titles right here. Let titles, I just declare the variable, but I don't define it. And then I assign the value here, okay? If I have another function somewhere else in my application, like put titles on DOM, right? And do just exactly what we did here, right? How am I ever going to call this function when I know for sure that the titles has values in it, right? We'll never know. It could take 10 minutes. It could take 2 seconds. But if I, at some abstract part or time in the future, whether it's immediately after or 10 minutes later, try to call this function, I'm never guaranteed to have that titles variable be populated with anything, right? So again, there are ways to do this, but I don't want to focus on them right now. Instead, always use the information when you know you have it for sure. I want to see everybody writing their fetch requests like this. Once you get the information, then do stuff with it. And to Burbage's point, go ahead.
So it's like, maybe I'm overthinking it. It's like you want to act on the info when you have it, as opposed to fetching the info and then later writing all these functions to act on that info, because the fetch itself initially could be delayed or something like that.
Exactly. Now, don't get me wrong. When we start building our applications with more complexity, we're going to start using something called state, right? State meaning the state of our application. We can use state to say who's logged in right now. What are the books that are being shown on the screen? Is our application in dark or light mode, right? There's going to be bits of information that our application is going to use, and that information is going to change, often based on the return values of fetch requests. So I'm not saying it's impossible or never correct to store information from fetch requests in a particular place. But what I will say is that for the purposes of this and for the purposes of this week, next week we'll get into a little bit more of how this is different when we're using classes. I just want to see people starting with this, okay? This is already a complex enough topic. I don't want us to be thinking too much further outside of this right now.
So Chris, like in some of the labs, they ask you to like fetch the info and then change the colors if you click on an LI and you know, do this and that. There's different components. Are you then saying that we should have all that functionality, such as right here we created a new LI in inner HTML on book list, and let's say the lab was like change the color of this LI if someone clicks on it. Are you saying that you'd suggest we put that functionality within this fetch?
No,
function?
that's different, right? if you do that correctly, then you should have an event listener. If you follow this kind of principle of one event listener to rule them all, right? Where you can click anywhere on the screen and then have an if-else statement that determines if the target was an LI. And then you can just go in and change the background color from there, right? That doesn't require you having made any fetch requests, right? That's basically the browser searching and saying, okay, is there something available on the DOM right now that we can change the color of? But that doesn't require making a fetch request.
Okay.
Does that answer your question?
Yeah, it does. Yeah, thanks.
So to get to Burbage's point, we can maybe break this out into another function. Let's kind of refactor here. I kind of like the idea of refactoring this out into its own function. We could say function put title on DOM. Oh, let me actually just paste this here and just give it a name. Function put title on DOM, right? That receives one title at a time. And we can pass the reference to it here. That might be the only thing that I refactor right now. We could make this one big one and say function, handle gbooks object, and we can get the gbooks object in here, and then grab all this, and then we can say, handle gbooks objects. If we want to do that. We can break that out into two other functions. But the way that I did it before with all of the functions just sitting in there is totally fine to do initially and then refactor later if you feel like you have if you feel like it makes sense to you. Right,
and
so go ahead.
And refactoring them and taking them outside of the first fetch, what does that do? Like, what's the positive part of that? Like,
it just makes your code look nicer.
Okay.
Right, maybe there's another place where we're going to use this. Now this is its own function. Maybe we want to put a different title on the DOM. Maybe we want our users to write their own custom titles and put them on the DOM. I can reuse this, right?
Oh yeah, that makes sense.
So now it's more modular. This is always going to do one thing. You'll see in the future when we start working with CRUD that our functions are going to have slightly different purposes, but if we write them in a specific way, they can be used for multiple purposes. Okay. So I think I've checked off all the boxes here. Fetches, built-in method of using the browser, make GET requests to an API, introduction to promises and using the duck then chain, exploring the limits of promises. It's kind of what I meant before, like we never know how long they're going to take to resolve, taking information from promises and appending them to the DOM, trying to follow this principle of never try to take the information that we receive from a fetch request outside of it. Let's use it right here where we know we have it for sure. If you follow this principle, then I highly guarantee you won't run into any problems. And just as kind of a recap, there are 3 things that I can think of that will be really helpful for everyone when approaching any kind of JavaScript problem moving forward, right? And if you don't know any of these, let's practice these during open office hours or any classmates that do feel comfortable in knowing this stuff. But the first concept that I kind of taught everybody about was the one event listener to rule them all. If it feels, if a bunch of elements use the same event type, right? The second one is this step-by-step process. I like the way that Ryan kind of delineated it for me, which was 1, select the elements that you need, right? Select the elements that you need that will change on the DOM. 2, add the event listeners to the elements that need them. And then 3, define your callbacks. And then the third one being the one that we talked about today. Use your fetch information. Use information from the fetch. inside of the dot then chain. Okay. If you have these three concepts kind of in your brain, I think that as far as functional programming in JavaScript goes, these will be very helpful for you understanding the basics. Cool, so I'm gonna start open office hours now. If you have any questions, please feel free to hang out. Otherwise, I will post the video and code as soon as I have it up. Okay, oh, John says, good question. What for me was a bit confusing is the name change in line 9 that made me wonder where the hell that came from. Line 11. Talking about this one?
Yeah, where the gbooks object came from.
Well,
in the lesson it was a little bit different, but.
So remember that the dot then will always, dot then accepts a callback function and will always pass the return value of the previous dot then into the next one.
Okay.
Right. So when I call this function in here, I'm expecting the return value from the previous dot then, right? Which I know is going to be that Google Books object.
Okay.
Right. So remember, we can just pass. We never want to invoke the function when it's a callback, right? We always want to pass it as a reference and wait for that dot then to determine when it's ready to invoke that function.
Okay.
Right.
Yep.
Okay. Okay. Stop the recording. So yeah, if everyone is here, then you're here for open office hours.